So there are sort of two schools of thought. You've got one side saying that everything in data science is being automated. Don't go into the field. Everything's obsolete. Data scientists are overvalued. Then on the other side, you have a lot of people saying that demand for data science is bigger than they've ever seen it. So how can both be true? How is it possible that you have two sides that can support their cases with decent amounts of evidence? How are they both right? Well, that's what I want to talk to you about in this video, is what side of data science and which aspects of data science are being automated and which sides of data science are not being automated. What can you do as a data scientist or someone trying to break into the field to make sure your career doesn't get automated? So let me start with nothing. Nothing in the world is better than just reality when it comes to sorting out a mess like this. We have two sides and they are equally compelling. So let's dive straight into some reality. This is LinkedIn. These are job postings. They're real ones. So let's walk through one of the reasons why a lot of people are saying data scientists are being automated and are correct. So when you look at jobs like these, one of the things that companies a lot of people will talk about the need for high-end technical skills. But let's look at this job description. There they are. We found them. There's 2 lines about technical skills in this job description. Let's go to Shopify. And let's look through there. We're still going. We are still going. And there we go. Found it. 1 line. That's it. 1 line. Hulu. Another great company to work for. Hulu. Let's look for, where is it? It gotta be up. There we go. Found it. And I'm going to come back to this. Object-oriented. This is something that's new. This is something that only over the last couple of years you've started to see emphasized. But look at all this job description, and here is where you find just a few lines about the technical skills. And they're not talking in the crazy terms that they used to. Now they're saying we just need proficiency, capability, and an understanding. You see that sort of language more frequently in job descriptions for mature companies. Now let's look at Spotify, another mature shop. And again, you're seeing the same thing over and over and over again. Technical skills are closer to the bottom. The roles are more and more focused on outcomes, key activities, work items. You're not seeing as much of this crazy list of technical skills anymore. It simply doesn't happen. And I can keep going through example after example after example. In this case, Microsoft. It didn't even make it in required qualifications. It's down here in preferred. It'd be really nice if you had experience. You notice excellent. Now we're talking about interpersonal and communication skills. You want knowledge and ability to work with. That is excellent. You'll hear that of almost all of them. Engineering. There it is, 1 line. And you notice how bare bones this is. This is just bare bones, what we would like you to have. And what you're going to be doing is far, far, far more in-depth than the technical requirements behind it. Instagram. Let's do them. I mean, if you don't believe me, I'm going to hit you with example after example after example. Again, it wasn't even in the minimum qualifications. Hypothesis testing is. Again, another area that I'm going to come back to. This here, it's just preferred. It's a nice to have. We would like you to have them. EA. Same thing. I'm doing this so you know I'm not cherry picking. I am grabbing mature organizations and showing you that the majority of what they are asking for is different than it used to be. One of the things which is being increasingly automated is this technical side of the role. That's why so many companies are not emphasizing those you remember those massive skills lists, the ones that I made fun of, back in 2017, 2018, where it was just ridiculous. There was no way you could know all of the things that they were asking for. Those are a thing of the past in mature organizations. Companies aren't focusing on that because for the most part, that model development side of the data science role is being automated. So the amount of code that you end up actually writing is much smaller than it used to be. However, there's a flip side to this, and I'm going to get to it in the gap skills, which we're going to talk about next, which is software engineering. Remember when I pointed out object-oriented programming? The move is from we need you to be able to code to we need you to be able to engineer and architect reliable systems that make it into production. That's a gap skill. That's not being automated. But everything else, everything about building out the hands first type coding activities, the syntax, all of that is now reduced. It's lessened because a lot of data pipeline work is automated and can be automated. A whole lot of your data wrangling is automated and can be automated. And this is something to focus on if you're trying to break into the field. Understand technical skills are critical. However, it's not syntax. I mean, there's even one job that was in here which says you are an expert at Stack. You are frequent on Stack Overflow. And it's a nod to the fact that most syntax type questions, the things that used to be important, you can Google it. And almost everyone in the field does. So that piece of it is no longer emphasized. Those hardcore technical skills are being automated. And so if you have based your career as a data scientist on hardcore technical skills, you're going to have an increasingly difficult time landing a data science role. Again, because that's just not the focus. That's being automated. So unless you're going into ML engineering, which I'll cover in just a second, unless you're going into ML engineering, those hardcore technical skills aren't going to help you as much because the type of data scientist who's primarily focused on model development, they're being automated. Now, another type of model that you're going to see increasingly automated is the descriptive modeling, which you look at people who have 5 years in the field. Many of them have never done anything more complex than a descriptive model. You can call it whatever you want to. You can call it a predictive model or a prescriptive model. But without that experiment, without the evidentiary support and the explainability to say, this is what the model does, this is how it makes decisions, and this is the experiment, or usually multiple experiments, that we've done to support inference across multiple classes, multiple behaviors. If you don't have that evidentiary level of support, it's simply a descriptive model. The majority of workflows, if you look back, the majority of workflows are gather data, wrangle data, train, test, and then validate on an external data set and then ship it to production. That's a descriptive model development workflow. That is increasingly being automated. You're looking at a lot of ML platforms that can almost do end-to-end all of that with very, very little intervention from a person. Those are low-skill tasks, and we're realizing that pretty quickly. They don't return a whole lot of value to the business, and so that is definitely under threat of automation. And if you read through a number of data science job descriptions, you're seeing that companies are specifically asking for people who have experience with experimental design, and we'll talk about that in just a little bit, but also in building more complex models that solve business problems. And we're going to talk about all of that in the next section when I talk about gap skills. So if you're looking for a way to direct your career so that it isn't automated, forget about that descriptive model workflow. That's insufficient. It's partial. And if you focus your skills training on just that descriptive model development, you won't really have a future. It'll be difficult to get into the field, let alone have any sort of longevity in the field. So those two pieces of data science are being heavily automated. That's why half of the people who are saying, oh, data scientists are worthless. Yes, if you've only ever worked with people who are focused on model development and building descriptive models for production, you're right. Both of those are pretty low in skills, and both of those are being automated. So the majority of data scientists who've never done that next step, who have never done more complex model development, who have never done the experimental and the research side of this, they're having a difficult time and their careers are being automated. So avoid that. And that's why I say both sides are right. They are correct that that's low value, low skill. Why not just automate it? So they're right. Now, the other piece that's being automated heavily, and this is where I want to go into a couple of data engineering jobs. And I want to explain, I want to show you the facts. I want to show you reality. Data engineering is being automated and encroached upon by machine learning engineers. So if you're looking at data engineering, you'll hear the narrative, hey, replace your data scientists with data engineers. So you might think, hey, I want to become a data engineer. No, don't do that. Over the next 3 years, you're going to see the majority of what a data engineer does automated. There are more companies than I can count who they've already got products at market. Companies are buying them and they automate end to end most of what a data engineer does for a living. The more complex pieces of data engineering, and let's get a couple of practical examples, the more complex, more difficult to automate pieces of data engineering are actually being offloaded to machine learning engineers. And Uber is a fairly advanced, when you look at platform and the MLOps, ML engineering, data engineering side, Uber is one of your more advanced companies. And they actually combined the role. And you're thinking, there's no way an ML engineer. But if you take into account what I just said about the amount of automation that's being done around data engineering and the amount of automation that is being handled by the platform, an ML engineer now has enough time to really take into account this entire workflow, where they are not just living in that traditional ops post-deployment, post-launch place. They're also being pulled further forward into the data science workflow, and they're also doing data engineering. And so you'll see this, and I believe this is a trend that's going to grow. You see it with a company like Uber, and here I'm cherry picking. So definitely if you go like a machine learning engineer from Comcast, it's a different story. They're still very much based on that back-end platform and model maintenance, model deployment. So there are some differences. Not every team is advanced to the point where like an Uber is. So this is what I say Uber's a leader in the field, and I believe that the field will kind of catch up to where they're indicating. And so Apple's another one of them, who I believe, they've got a very advanced platform. And if anyone is going to tell you where the field is going, looking at their job descriptions are going to be a good indicator of where the field goes for machine learning engineers. And again, here you're seeing signs, Spark, Kafka, Cassandra, Databricks, you're hearing it. This is all pipeline side infrastructure or pieces that probably touch data pipelines. So there's another job description where we're going. I believe this is where the field ends up going. Twitter, again, another really, really advanced platform. And again, they're talking about working on the pipeline development, working on building out for not just your traditional machine learning engineer, back end, working on that maintenance and model monitoring and those types of pieces and continuous improvement, continuous retraining and so on. I believe those are still going to be big roles for for machine learning engineers, but the data engineering side is being taken on more. People are hiring machine learning engineers to do not only that back end, but more of the front end. And that's only possible because we have platforms that automate so much of the data engineering role that a machine learning engineer now, because they're freed up a little bit by automation on that back end and through the middle piece of the data science and machine learning workflow, they also now have enough time and bandwidth, and they really have the expertise as well to do a lot of the pipeline development and manage just that end-to-end platform. Now it's falling under a single domain and under a single role, and using an ML engineer far more efficiently. So if your career is highly technical, if you have a lot of time as a software engineer potentially, or you've done some architecture work, ML engineering is an excellent place for you to transition your career. It's far better than data engineering because a data engineering role, like I said, it's under threat of automation. If you look at Microsoft Build, that really for me was kind of that was enough proof. That's all I needed to see. The work that they're doing and what functions now, they're not just showing like, here's our roadmap. They're showing functional product. that automates so much of the data pipeline creation, data cataloging, data discovery. So much of it is functional now that over the next 3 years, I only see these platforms becoming more adopted, more prevalent, and really automating a whole lot of the data engineering side out, as well as watching the continued trend where companies like Apple, Uber, and Twitter, very mature platform companies, I think you see that trend extend into other companies where they bring a machine learning engineer in, and that machine learning engineer now handles the entire platform, not just their end MLOps piece of it. So data engineering is a role that I see, they're right. I see data engineering being automated out. It's a danger to go in that direction. Now, when I talk about the ML engineer, I just want to highlight one area that I think is under threat. And I mentioned this briefly, but when you talk about deployment, support, continuous retraining, all of those are increasingly being automated. So if you're an ML engineer, you're going to be asked to be more of an ops and platform manager, as well as someone who's creating custom components for platforms. That's a great area to be in, but don't focus your entire career on heavily monitoring and all of that back end sort of maintenance phase, post-deployment phase work, because much of that's being automated. So you'll manage the platform, but you'll manage it in more of an ops fashion, making sure that what gets into production stays functional and is reliable in production. Focus on that. Don't necessarily focus on a lot of the traditional ML ops heavy sides, because like I said, as an ML engineer, you've got a great career. You're not going to be automated. However, you're going to be owning the whole platform. So don't just focus your career on one small piece of that platform. So I want to make that clear. I like going into data engineering, but I really want to tell you, go into data engineering understanding that as a data engineer, you're going to be doing a lot more than what most data engineer roles ask for now. So that's the piece I believe, those are the pieces that are going to be automated. Those are the areas to back away from and not focus your career on. So what should you focus your career on if none of those sort of more traditional, better known, more standard sides of data science and machine learning are going to be automated out of existence? First place, and I talked about this, applied research. The experimental design, execution, and then publishing, not research, but publishing artifacts, things that can go into production or that can be used across multiple projects. And an ML engineer might come in and apply them to a particular business case and deploy it to production and support it. That research side, applied research, that's someplace to focus your career because that's very difficult to automate. Now, parts of that are going to be end-to-end automated. If they weren't, we wouldn't be able to do applied research. I can't explain to you how complicated it is to run the number of simulations or compare the number of model architectures that are possible, the number of potential feature combinations, or even feature engineering methodologies that you may bring to bear to find all of the different available data sets and make the decision about which combinations of data should you try. How do you start pruning down features and figuring out which are the features that have the highest impact on your actual model performance, and then trying to figure out which one of those features actually means something with respect to the system, which ones have stronger association, even going to the point of causal analysis, doing causal modeling. That's hard. When it comes to how much work that takes, it's insane. If it wasn't for automation, you couldn't do applied research. And so automation in many ways is making it possible for applied researchers to do their job. That's why you're seeing this emergence happen now. And for an applied researcher, automation's an amazing thing because without it, we couldn't do our jobs. It's just simply not possible. These experiments are extraordinarily complex. So automation in this case is actually helping your data science with respect to applied research. The second place that more of a traditional data scientist is going to have success in is intelligent automation. Now, what that is, You've got robotic process automation, which was just rules-based automation. Anything that was hard-coded, didn't include any sort of intelligence or logic beyond really a whole bunch of if statements. This is what people used to think data science was. That's why that joke's out there, where, your decision tree is just one massive if else if statement. That's not wrong. That's what RPA was. Robotic process automation was just a whole bunch of if statements, and descriptive models were underneath all of these, and that was being called data science, and that's what's being automated. But intelligent automation uses actual data science and machine learning to build models that handle some of the intelligence work. So a lot of drudgery that takes low skill, you can use fairly simplistic models. You obviously have to do a little bit more than just descriptive modeling, but you can use fairly simplistic techniques and get a whole lot of bang for your buck. You can automate a whole lot more than a rules-based engine could when it comes to all the work that people do within a company. And so much of it, especially knowledge work, searching for the right document or searching for information or searching for resources. It's so time consuming and very simple, your natural language processing and natural language understanding. So much that those basic models, especially pre-built stuff that just needs to be customized and retrained and then deployed, so much of that is extraordinarily valuable and can do more than robotic process automation can. So intelligent process automation or intelligent automation, it's a good place to look at pivoting your career. Potentially, if you're in the descriptive modeling space and you need to make a quick pivot, it's really easy to come up to speed on intelligent automation and become one of the people who's doing the automating. Make that your career while you're learning to potentially go whichever way your passion lies, whether that's ML engineering or applied research. You could make a pivot out of a pivot, but that'll give you some longevity. Going towards that intelligent process automation route, using fairly simple established mechanisms and expanding them slightly, retraining them, and deploying them to enormous impact on the business. Now, when I talked about machine learning engineers and their automation, the future for a machine learning engineer is what I call full stack, and I hate that term, so I really want to say full workflow machine learning engineer, and that's what I talked about at the very, very beginning, where we said they're going to run end to end from sourcing data all the way to supporting models in production, owning that platform. So not necessarily knowing all areas and knowing how to do every piece, but knowing how to build platforms that do all of the automation that we've talked about so far, that's going to support greater productivity for data science researchers, intelligent process automators, and even the citizen data scientists who now can use ML platforms to do a lot of their analytics work. They can build their own dashboards. They can do a whole lot of things in self-service. They can even build pipelines on their own. And that's being supported by a full stack or full workflow machine learning engineer. So that's a great place if you're a data engineer and you're looking to get out of a field that's probably going to be automated, looking more at that full stack because you already understand that front end, which ML engineering is going to get pulled into anyway. So you already understand most of what an ML engineer does. Extending out your skill set to that rest of the workflow, rest of the stack, and you have pivoted into a job that's better suited to actually be one of the people who's doing the automation rather than one of the people who is getting automated out of a job, which obviously you don't want to do. If you like strategy, one of the gap skills in data science is the strategy side. And if you read job descriptions, you'll see increasingly companies are looking for data scientists who can create business impact. And that's going to mean a whole lot of business acumen and understanding how to translate your business needs and your business case to projects and products, which will either increase efficiency, make the company more efficient, save money, potentially that intelligent process automation. That's one way you can save a company money, or that have an impact on the bottom line. They are novel products or functionality that could not exist without inference, without that model. So those are areas where you're seeing a product management role emerge as increasingly important. There have been product managers in machine learning for a very long time, but companies are beginning to realize how important it is to sort of separate a lot of that strategy and business acumen work from the data scientists, especially as they go into applied research. Applied research, as I've talked about before, that's a lot of work as it is. So asking an applied researcher to also be a strategist who goes out from team to team and figures out what their business needs are, and you're hearing it, it's a lot of work. Companies are splitting that out. And so even though you see a lot of roles right now in data science asking for someone who can drive business impact, more and more companies are, yes, definitely expecting that out of their data scientists, but also creating these supporting roles like the machine learning product manager who help. So it's not all on the data scientists to figure this whole thing out, to get to users, spend time with stakeholders, elicit business needs, sit in with the C-suite, understand exactly what those business needs are, analyze the strategy. You can hear it. It's too much. That's just too much for somebody who's then also going to do applied research and push models to production. It's way too much. So you're seeing this splitting. And if you like strategy, I say this a lot, data science, machine learning, the strategy side is a gap skill. Increasingly, businesses need it. They realize they have to get models into production that don't just work. They create value. They either give you revenue or cost savings. So it has to work. It has to work for the business. There needs to be that connection between strategy and the model. But it's not necessarily always going to be driven by one person anymore. So if you have strong strategy and business acumen, great direction to look at, because that's really hard to automate. So you're future-proofing your career a little bit. And finally, this one's not for everyone. Most data scientists really never see themselves going into leadership. And if you're early or mid-stage in your career, that's probably where your head's at. But if you like leading, if you like having impact across the team, potentially even across organizations, leadership, you don't automate leadership. It's going to be one of those capabilities that is very much future-proofed. If you can lead a team of data scientists, ML engineers, and all of the other roles from analyst to ops, it's a huge team now. It's cross-functional. There are so many smart people on this team. And so it takes somebody who understands the, rainbow array of roles, what they actually do, and what they need in order to be successful. What does it take to support a data science team or organization? If you're a leader or you're interested in leading, that's a future-proof role. It is very hard to automate even management tasks, let alone leadership, because there is so much intelligence and thought work that goes into it. There's a motivational side of it. There's a mentorship side of it. There is problem solving, conflict resolution, managing up and talking to senior executives, talking to the C-suite, you can hear it. It's communications. It's the real collaboration, not the buzzword communication collaboration, but for impact, where your time with other people yields some sort of tangible work product or increase in productivity. That's a leader. It's someone who can make a team better, who can build capabilities, who can be a mentor, who can be a multiplier. That's something that just can't be automated. And I don't think it ever will be. I think we'll have to automate the entire team first, and then you won't need a leader. But I don't think we're anywhere near that. So those are the main areas that you should look at and think about. If you're worried about automation, if you're listening to both sides of that argument and saying, yeah, I'm kind of worried, where should I go in my career? So you want to avoid data engineering. You want to avoid being a descriptive modeler or a straight up model developer, somebody who does the code, not the engineering and the architecture side of it. And someone who's focused on just that back end, MLOps, traditional MLOps, narrow focus of deployment support, continuous retraining, continuous improvement, redeployment. Those are all at high risk of automation. Now, gap skills. your applied research, your intelligent process automation, your actual software engineering, software architecture, sort of that full stack, full workflow, machine learning engineer. That's not going to be automated anytime soon. You've got your machine learning product management role, your connection to revenue. You've got just that general strategy umbrella. And finally, you have leadership. Those are going to be more future-proofed roles because those are gap skills. Those are skills companies are having a hard time finding in data scientists to begin with, and they're very difficult, or they actually benefit from automation that's going on right now. So if you're looking to future-proof your career, that's how you do it.